Our topic is what is inertial and non-inertial frame of reference. The types of reference frame are inertial and non-inertial frames. Depending upon the Newton's law are applicable or not applicable. Before studying about inertial and non-inertial reference frame, we have to know what is a reference frame. A frame is a coordinate system with time frame is called frame of reference or reference frame. Now, for understanding, we will take examples as you are sitting in a park and your friend is riding cycle in front of you, but you and your friend are not sharing same frame as you are in rest frame and your friend is in moving reference frame. But interestingly, in that same time, although you are sharing same reference frame with a far distant object like Eiffel Tower or Taj Mahal, etc., objects are in rest. So we can divide or differentiate the reference frame in rest and motion depending upon velocity but not distance. And this concept was a little simpler. But can we say which among the given example are inertial and which are non-inertial reference frame? Answer is all objects are at rest or inertial reference frame, as by definition Newton's law are applicable here. These are you are sitting at rest, Eiffel Tower, Taj Mahal, etc. But what is about your friend who is riding cycle in front of you? Answer is it may be either inertial or non-inertial reference frame. When the cycle has constant velocity, it is an inertial reference frame, but when the cycle has a velocity with acceleration, then it is a non-inertial reference frame. Because a force is being applied on frame, and due to this acceleration, object on this frame also feel a pseudo force m dv dt not equal to 0, as v is not constant, and you can easily understand that the frame itself accelerated. So Newton's law are not applicable or become complicated here. That is the main concept about inertial and non-inertial frame. Now you can stop the video or can continue. Actually, now we will enter into the calculative explanation of non-inertial and inertial frame and how the Newton's law could be generalized in both frames. In Newton's law of motion, there is no mention about coordinate system. Let's see, is there any importance of coordinate system or reference frame? Let in S frame, Newton's law are completely applicable, and S dash frame which is moving at velocity u with respect to S frame. A particle in motion having position vector r, and in S dash frame position vector is r dash. It is assumed that initially or at t equal to 0, S and S dash frame was in same position. At time t, S dash frame has velocity u. If u is constant velocity, so force on S dash frame equal to m du dt, which is equal to 0. So no force is applied on S dash frame, and Newton's law are applicable on this frame, and this time S dash frame is inertial. But if the u is not constant or changing with respect to time, then Newton's law applicable on S frame but not on S dash frame. In S frame, F equal to ma, but in S dash frame, it will be F equal to m du dt plus a, or F minus m du dt equal to ma. We have added m du dt to keep Newton's law purity in S dash frame.
Here m du dt is a force which varies with particle mass. Although the force is not depends on the particle, neither there is any interaction between, but we are calculating particles motion and with respect to du dt accelerated s dash frame. So in final equation the properties of both like m, f, du dt are coming. The force m du dt is called pseudo force as no interaction between particle and s dash frame. So F equal to m du dt plus A is a general formula for all inertial and non-inertial frames. For inertial frames only du dt will be 0, and then we will get a force equation F equal to ma.
And that is our very well known Newton's law of motion.